In example 4, we're going to use graphing technology to evaluate the limit as x approaches infinity of x to the 50th divided by 2e to the 2x. And when we put that in the y1 and then zoom 6 to look at the graph, it looks like it's coming down, decreasing as we approach 0, and then increasing as we approach 0 from the right. So decreasing from the left towards the asymptote, or towards 0, and then from the right we're coming down towards 0 as well. If we look at the table, so second graph to get to the table, we can see in the negative values of x, remember that e to the 26 is 1.4 times 10 to the 26th power, so it's a really big number. And then down to e to the 16, so that's 3.1 with 16 zeros. Then when x is negative 1, 3.6945. Now we're at reasonable numbers, we're getting close to 0. At 0, we're at 0. So the limit approaching 0 from the left side is 0. From the right side, we've got really big numbers, right? E to the 30th, that's 2 with 30 zeros after it. So again, really, really high. And then as we go to 0 from the right side, we're getting closer, closer, closer to 0. But this limit, instead of looking as x approaches 0, we're evaluating x at really big numbers, at infinity. And as we go up, up, up in the table, it looks like the numbers are going to infinity, but we have to be careful. So if we go to our table set and change this from auto to ask, then we'll go back to our table. We can type in some big numbers, like 100, and see we get an error. If we put in 50, there's our 1.7 e to the 41, so that's really, really tall. But as we get closer to 100, we're getting closer and closer to that error issue. So 99, we've got 3.1 e to the 13, and 99.5, right now we're at another e to the 13. So if we look at, as we go from 50 to 75 to 90, do you see how these numbers are coming back down again? And that doesn't seem to mesh with the graph that we look at. So when we look at the graph, see how it looked like we were going up to infinity, that limit was going to keep